Hey, D-Dexter here, another great math video for you. Today we're talking about graphing a hyperbola from the center or the origin. Alright, so let's take a look at some basics here. We've got basically two different forms that we want to consider. We have x squared over a squared minus y squared over b squared equals 1. And we also have y squared over a squared minus x squared over b squared equals 1. Well, what's the difference? Well, one of the main differences is when we drew an ellipse, we looked at who was the greater value. And a value was always placed under who was the bigger value. That was always determined our a value. Well, in a hyperbola, the value that's under the one that's out front is always your a value, okay? So the one who's out front determines whether the branches, this is a branch and a branch, whether they will swing, they will go out or they will go up and down in the y direction. So in this case, an x squared is out front, so our a value will be here. So again, the branches go to the point out in the x direction. Again, on this side, they are equidistant from the center. They are a value from the center. So recall that if this is a squared, then we take the square root of that and you get the a value directly from the center to the outside, which is the vertex. So right here, we'll have a little point which is the vertex of our branch. It's like a parabola, but it's part of a hyperbola. So, and we'll also have another vertex on this side, and then we'll go through that. Now, b value, what do we do with the b value? In this case, well, the b value will determine a height or a width, right? But we're going to have to look at that a little bit more closely when we get to some examples, because we're going to draw a little box method, and that the a value will go from the center out to the x, and then the b value will go up. C, again, is your focal point. So the foci, or the focal points, the foci, however you want to pronounce it, is c squared is a squared plus b squared. Remember, an ellipse, it's minus, but now we want to go outside, so we're going to add those values together. So the value of c will equal plus or minus the square root of a squared plus b squared. Okay. If we look at the y squared out front over a squared minus x squared, now, again, we see that a is still out front. A is always out front in these. And the b value will be under the secondary one. If we have y out front, now we're in the y direction, so our branches will go up towards the y direction or down in the negative y direction. All right, and that's the basic format. Again, you've got a vertex here and a vertex there. Your focal points will be outside or tucked inside this little bowl, if you will, but it'll be away from the center, all right, the origin, 0, 0 here. All right, let's look at an example. Example number 1. It says x squared over 16 minus y squared over 9. And we see that a squared is 16, so a is plus or minus 4. And under the y category, we have 9, so b squared is 9, so b is plus or minus 3. So when I go to graph this, what I'm going to do is I'm going to first, the a is under the x category, so again, I just follow that same, go out 4 units left and 4 units to the right, okay? And so I put those dots in blue because that's my major axis here. And then my y value is up 3 and down 3, negative 3 here. The negative got kind of cut off there, but that's supposed to be negative 3, right? And so my focal points, again, are plus and minus the square root of 16 plus 9, which is the square root of 25, which is 5. So I went ahead and drew those in as well. So we have a focal point here at -5 and at 5. Well, now it's time to draw the branches. And this is where we're going to create a box. So what I've done is I've created a rectangle, and it's fairly easy. All you do is you take your endpoints and you go up to where the y value is, you go down, and then across. So just picture this as a box. You say, well, how do I know what's there? Well, if you keep going to where they intersect, that will be the edge or the corner of your box. All right, so what do we do with that? Well, I'm going to slide over here. What we do with that now is I'm going to start at the center, and all I'm going to do is draw another set of asymptotes, and they will go from the center to all 4 corners. Okay? All 4 corners. One more. All 4 corners like this. Now, this is an X out in front, so I would expect to see that the branches will go to the outsides, and that's in fact what they do. So if I draw this, I'm going to start here, I'm going to hug this asymptote, come into my vertex of 4, and draw my line like that. My curve. Same thing here. Start on the outside, I curve, and I hug my asymptote, and I draw my branch like that. All right? And that's basically all you do. It's X, it's going in the X direction, and so we're good. All right, let's look at another example. Example number 2. This time, y squared, and we have a lower value, right? 9. And then x squared over 64. Again, if we were doing an ellipse, we would care about who was the bigger number. But all we really care about is who's out front. And that will determine which direction the branches go. So a squared is 9. A is plus or minus 3. B squared is 64. So B is plus or minus 8. C, that's the value of our focal points. The plus or minus the square root of 9 plus 64. Well, 64 and 9 is 73. So the square root of 73, well, maybe you're thinking, well, I'm not sure where the square root of 73 is. Well, think about it this way. What's the square root? I go to the perfect square above that number and a perfect square below that number. The most perfect square below is 64, which is 8. Perfect square above is 81, and that is 9. So square root of 73 has to be somewhere between 8 and 9. All right, well, let's keep that in mind as we look at the graph. All right. So, again, I've got, I'm going to be 8 units in the x direction, so I'm going to go out -8 units from the center, and to the right 8 units from the center. My y value is 3, so I'm going to go up 3 units and down 3 units. So again, I'll draw my little box that connects all these dots. Now remember, it's not an oval in here, it's just a regular rectangle. Practice drawing those boxes. They connect. Where are my focal points? My focal points were between 8 units and 9 units, so I place those on the I placed those 8 units. Oh, yep. All right, so I'm going to correct this because we are in the y direction, so I'm going to actually be going up this way. So what we need to do now is replace those focal points, and they are between 8 and 9 units. So 3, 4, 5, 6, 7, 8, 9. So 8 and 9. So I will have a focal point here, F1, and then I need to go between 8 and 9 units down, so we're going to have to extend this a little bit. It's okay. 4, 5, 6, 7, 8, 9. So -8, -9. Okay. And then we're going to be we'll have a focal point here. So that's focal point 2. So we have focal point 1, focal point 2, and you're like, well, that seems like a long ways away. Well, what happens is because the branches are so wide, that focal point needs to be further away. If you know some things about this, the focal point is always where the information gets collected off the dish and goes to the focal point. So again, I'm going to draw my arrow. I'm going to put my asymptotes from the center out to the box, through the corners. And hopefully yours might be a little bit straighter than mine, but that's okay. Just a sketch. And now I think, okay, well, Y's out front. So since the Y's are out front, I would expect that the graph would go up like this, and that's in fact what they do. So my curve then will come down, go through the 3, and then go and follow the asymptote that way. This one, same deal. I hug here, I go through the 3, I come down, I hug that asymptote, and there we go. And so there's my focal point there and focal point there, and that is our graph of y squared over 9 minus x squared over 64. It's great. Good time, right? Not too bad. All right, well, that has been graphing hyperbola from the center. I hope you've enjoyed the show. Be good. Keep it mathy and enjoy math. See ya. Peace. D. Dykstra out.